This is just another example of being lean, of making it smaller, lighter, taking away everything you can and have it still function, as well as those Rube Goldberg designs where they're massive and they've got all these dials and adjustments and they take a lot to build, and they're kind of an engineering feat. Well, in my opinion, the real engineering feat is to do what those will do in something simple like this. Perfect square. I love this crosscut jig on the Polk Smart Bench. It just makes breaking down plywood so straightforward and so simple. The base of my mini crosscut sled is prepared. I cut it from a 12mm piece of ultralight ply. This is like an AC ply. It's 18 by 18 and it's a perfect square. I made the rails from a scrap piece of 1x2 PVC trim, that's exterior trim, ripped it down and thinned it so that it doesn't bottom out in the miter track on the table saw. You want to leave some airspace, cut and recut until I had it just right. I put some strips of plywood to hold PVC up flush with the surface. I tested multiple glues that I have in the Smart Wood Shop, and I came up with my best option as being this thin 2P10 gel without activator. I tried it with activator and without, and I found that with activator it was more brittle and it was easier to pop off. The other advantage of not having the activator is instead of having just a couple of seconds to set it, I probably have something more like 30 seconds. Alignment is simple. Now I just push the base up against the fence and make sure that the rails in the back are flush. That was easy. Now a little pressure. These dominoes come in handy for lots of things. The base for the mini crosscut sled is ready. I'm ready to move on and make the fence. I decided to make the fence 5 inches tall, and that's because I want the bridge to be a full 2 inches. When the blade is fully deployed, it sticks up about 3 inches above the base, and so that will cut through 3 inches of this, leaving about 2 inches, which will be the bridge. That'll be what holds everything together. I'm going to make the fence from 2 pieces of 18mm plywood. So the next step is to rip enough 18 mil. Next, I'm going to cut a T-track in the face of the fence. To do that, I'm going to use this white side T-slot cutter. This cuts a really nice T-slot with a bit of an angle on it. Great for putting clamps into. I've shown you this before. This is far superior than my previous white side setup, which required 2 different bits. I'll take this bit and the T-track I can make directly in my plywood over 10,000 feet of aluminum T-track. Now I'm going to laminate these 2 pieces together. Time to make this cut. Question, how would you do this? I could put it on the miter saw and make this cut through. I could do it on the table saw with the miter gauge, then rip it through here. The rip, of course, the blade on the bottom would be reaching further through, so I would have to stop short and then maybe finish the cut with a Japanese pull saw. Do you think that's how I'm gonna do it? Of course not. I'm gonna do what I always do. I'm gonna choose the most versatile saw available to carpenters. That's right, the router. As usual, I'm using a bushing and an upcut spiral bit, so I need a pattern to follow. When I was making the 2 pieces of 18 mil for the fence, I went ahead and cut a piece of 12 mil. I didn't even need to draw these lines or lay it out on the fence because the pattern will be doing it for me and save me from having to remove those marks. I knew that, but for sake of the video, I wanted to walk you through the process. The cool thing about the pattern is it doesn't matter if I overcut it. Now to the miter saw and the table saw with the pattern. It was such a short rip that I just did it on the miter saw. So there it is, the pattern in 15 seconds. I'll make multiple passes. I'll plunge a little bit and then a little bit more. I'm using a 1/2 inch cutter, so I don't want to cut more than about a 1/2 inch deep on each pass. Now it's time to attach the fence to the base. I'm going to screw in one end where it's going to permanently be, the right end, and on the left end I'm going to put a screw in, and that one may move when I test it for square at the table saw. I'm going to have additional holes along the way. I'm going to pre-drill everything, but I won't drop those screws in. They'll be the final touch. Since the base is perfectly square, I'm going to mount the fence just square along the back as a starting point. The first pass on the table saw will be to establish the kerf on the sled. Essentially, I'm going to cut the base of the sled in half. At this point, I need to be very careful. The blade is also going to cut all the way through the fence. It's going to be exposed on the backside and spinning. Make sure that I don't cut myself. I want to keep my hands to either side. The good thing here is by having these drops, I know the blade is going to cut through the middle of the bridge, which is 6 inches wide. So I'm going to hold my hands out here. I'm going to make sure I stand way back, pass through that. I'll see it coming, and then of course I'll stop at that point. The base had a right and a left because the miter tracks are offset differently, and I wanted this kerf in the center of this bridge. So I have a choice right now. Take it off of here, spin it around and mount it over here. I'll have an extra little kerf cut in it and move it over, or I can leave it where it is. I'm going to leave it. If you're making one, pay attention to that. To attach each end of the two separate pieces. The reason that I'm having this problem that I've never had making a sled before is that I do not have a front bridge. That's on purpose. I decided when I was making this minimalist mini sled that I wanted to see if I could make it without the front bridge, which of course would be holding the pieces together here and there so they wouldn't float. I want it that way because of size, bulkiness, and also it does allow me to do a longer piece if I am doing something creative. But really, the main reason is I just wanted to do it with less material if I didn't need it. I can always add it if I find it to be a problem. My original idea was 2 rails coming right off the fence made out of hardwood, but I decided against that, even though that would be more minimalist. I decided that I would be spending more time and energy protecting it when I'm storing it and moving it, whereas this way, this is much more durable. And doing this base, cutting it on the wrong side, that's a total blunder on my part. I knew about that and I planned on that, but I forgot when I laid it out. Another error that I almost made would have been expensive. When I did my screw layout, I put one right in the center. Had I had my blade go right through there and had the screw already been installed, I would have cost myself a blade and a brake. Of course, I didn't have the screws in there on purpose, so I wasn't in any kind of risk of that happening. And when I flipped it over, if I had cut it in the right spot, I would have seen the kerf going right through my countersink, and I would not have put a screw in there. But I definitely want to be careful that I'm not too close. I know the blade is going to go there, but again, metal and a saw like the SawStop don't go well together. I'm using one of the most accurate tools that we have, and that is to put things together by feel. Assuming that I have a straight edge and that it's square, by having my finger making sure they're flush, a whole lot more accurate than me trying to do it by eye. Now I'll check for square doing the 5-cut method. The 5-cut method allows me to check for square a few different ways. I can cross tape. I have 270 millimeters exactly on both. I already know this is going to be good enough for what I need it to do. But the 5th cut takes a sliver from the 1st and the 5th, and checking that it's uniform all the way through lets you know how far off it is, because the error is multiplied. I made another video years ago when I made the bigger crosscut sled that I wanted to be very precise. I'll put a link to that video in the description down below, and if I remember, I'll try to put it up here as well. 691 and 698, 7/10 of a millimeter off in 8.5 inches or 217 millimeters. That amount is off it's a compounding, so it's every time you cut it, increasing the error. This is one of those things, if I were cutting a spline to fit in a groove, this would be perfect. Check it for square with the square. This one is TSO's 18-inch triangle that is machined to 1/1000th of an inch. It's absolutely perfect. It's no magic or fluke that it's square first try. When I made the base, I used the crosscut jig on the Smart Bench, which leverages the MFT holes, the 20 millimeter holes, which are CNC quality for square. So when I cut it square there, I got this 4-way cut on that to begin with, and all I had to do was flush the fence up to one edge, and I knew that it would be square. I'm gonna make the safety block now for when the blade comes through the back. This is critical and not optional. This must be done. No matter how careful I am, and with my hands off to the side, having a spinning blade come through the back side of this is a recipe for disaster, because distractions happen. You want to make sure that you do everything so that your tools are protecting you rather than hurting you. To do this block though, I want to maximize the potential of the blade to come through, meaning fully all the way up, because there may be situations where I do want to cut up that high, which is the reason that I made this fence so tall, so the bridge could be well above the point that the blade's going to come up. In addition to making the safety block tall enough, I also want to make it deep enough in case I cut a little further than I really need to. Sometimes I want to have that little margin of safety. So even though that is about maxed out and there's no reason to go any further, I'll go a little bit past and make a square block, 110 millimeters. I attached the safety block with just wood glue, and then I clamped it and left it overnight. When I glued the three 18 millimeter blocks together, I used a couple of screws in both sides as temporary clamps. I'm going to remove those because with the blade going through, I just want to make sure there's no opportunity for the blade to hit metal. Now I'm going to attach a piece of tape measure to the face of this. I'm going to use this fast cap rule. This is the stuff that I use on all of my workbenches, the Total Station. I like it so much. It's the absolute best on the market. It's very legible. In fact, it's the same scale and readability I have on the tape measures I use. It's metric and imperial and just so easy to read, and it's got all of the proper markings. This I buy this flat stock, and it's 16 feet long. What's really cool about it is they print it on both sides and it's reversed. So being that it's 16 feet, if I happen to need an 8-footer reading left to right and an 8-footer reading right to left, I can buy one piece, cut it right in the middle, and just install it that way. They're pretty ingenious how these guys put that together. I'm going to be taking such a tiny piece off to do this. You'd think I might be wasting this. But the beauty of it is when I set up a lot of my jigs and fixtures, they're offset from the blade some distance. In my case with my Total Station, the scale starts at about 13 inches. So even though I'll cut off about that much, I could use this on another Total Station. This is metal, and I definitely don't want metal coming into contact with the blade to potentially activate the brake. It doesn't really matter if I have a 0 right up to it. So I'm going to take off to a 1/2 inch. I'm going to start it at a 1/2 inch. I made a simple block, drilled a hole in it, and put one of these T-bolts in with a knob. This is so it'll slide into this track for repetitive cuts. Primarily, I want to be able to use this tape measure without the block. Most of the time, I will not bother with this block. I'd like to be able to, whatever material I have, if I want to cut it to, say, 5 inches, I'd like to be able to put the end right on the 5 and make that cut, and I'll get it. That means that for the block to work, this outside edge is going to have to fall right on that same number. These fast cap peel and stick rules, because they're reversible and printed on both sides, they don't come pre-glued with a peel and stick. Rather, they include a roll of their double stick tape, which is another product I use quite a bit. If you're wondering if FastCap sponsors this, and that's why I'm talking so favorably about their tape and their tape measures, they're not. This is just what I use, and I have found to be the best of the best. Now, the link that I provide in Ron's store, or the links, most of them are like from Amazon, and Amazon does give us a percentage if you use that link. But again, that's not from FastCap. I want the tape to go right to the edge. So rather than trying to flush it up to the edge, I go ahead and put it on right where I want it and overlap, and then I cut the tape off. It's really important to, I found with these sticky tapes, to get them stuck right to the edge, because that's where things will start to, you know, in mobility and moving things around, storing and pulling things in and out, that you'll sometimes, that's where you'll usually hit it, is right on that edge. My mini Crosscut Sled is complete. I like it. It's much lighter than the other one, and for the kind of work that I need for cross-cutting, this is going to be perfect. Now, I made a few mistakes. I pointed them out in the video. They're not a big deal, but this being offset a little bit instead of centered actually turned out to be a little bit of a positive, in that it gave me a little bit more room for my measurement on this side. Again, not a big deal. If I had it to do again, I would center it, or at minimum, my bridge I would have moved over. So as you can see, my hand on the right side, if I tuck it up next to this bridge, which would be something I might just do without thinking, this side is a little closer to the blade, and if it were centered, then it would be kind of even. The other thing that I am not sure about, and I may modify on this one over time as I use it, is I didn't want a bridge on the backside, which I typically and have always put on, just because I wanted it open, I wanted it lighter and simpler to store. What I might have done different, instead of making the base 18 by 18, I could have made it 18 wide and maybe another 4 inches or so longer, and then cut away some material here, creating sort of a flat bridge, and then drop it for that first cut, drop it on the saw so that the kerf is starting where it is now, but there would be more material behind. The one thing about that is I would always have to drop it onto the saw like that, because it would be a closed-in kerf. That may or may not be an issue over time. It seems pretty strong right now, and it's certainly much stronger than my first thought, which was just to put some hardwood rails sticking out. They would have been a lot more fragile in storage, in my opinion. When I drop it on, of course, the rails are going to lock in to the miter tracks, so it doesn't really matter if these are floating around a little bit. They're going to be pulled back in. Since this is so small, I'll keep it near the saw, just probably sit against the wall here, or I might even come up with a hook or something on this side. But again, because it's so much smaller and lighter, this will be easy for me to pull out. If you like this idea of a mini crosscut sled and you see a need in your shop, then just watch the video a couple of times. None of the dimensions are mission critical. You can design it and scale it to fit your needs. I just recommend that you bias toward the smaller side, because I think you'll find there's a lot of use for that, probably more than a larger one. And if you need a bigger one, just make a separate bigger one, but go ahead and make yourself one of these as well. The time to make it is about an hour or less, with the exception of waiting for glue to dry. I actually started it yesterday and finished it today, mainly because I let glues dry and had other projects to do. And the materials, most wood shops are going to have stuff like this laying around in their scrap bin, so you don't even need to go to the store and buy anything. So take advantage of that and make yourself a handy little tool. And speaking of simple and effective of cutting it down to just what you need, if you want to build yourself a smart station like this one, a smart workbench, a smart cart that makes them mobile, or any of the accessories that work with the system, or a smart wood shop like this one, all of those tools, those benches and carts and everything you see in my shop that I'm using, all fit in here, and then I can take it to the job site in this 8 by 12 foot trailer. This has been designed over decades and has been really refined. If you want to get any of these detail plans to build these for yourself, you can click on the link down below. You can go and pick whatever plans you want, and there's even packages if you want more than one that'll save you a bit. And then as soon as you make the payment, you'll get an email from us. You click on the link and you can download the plans right then, instantaneously, 24/7, 365. Mahalo.